Florian and Kevin here have kind of evolved the process to the next step of the evolution. So without any further delay, here's Florian Friedrich to go over the test disk that you will all be hopefully using very soon. We're going to keep this lively and open to discussion, so if you have any questions, I'll hand you the microphone as long as the cable will allow me to. But raise your hand and scream it out. But thank you, Florian.
Thank you, Jim. So let me find remote controls. Good. Some of you have seen a few HDR test patterns already in previous sessions. However, let's start out with the fact that we cannot use SDR test patterns for HDR. The levels are completely different, and our approach of adjusting and calibrating, even evaluating displays for HDR is completely different than what we are used to do with SDR. I would like to start out with some basic things. We will go over a workflow afterwards, Calman workflow. So Kevin is going to present this workflow that I had created most recently. And this is working with the disk only, so you don't need any generators. And all of this is part of Samsung's effort to support the whole HDR ecosystem. So obviously many people are in need of understanding HDR and utilizing all the capabilities that the system has. So this, as an example, is a plooge pattern for HDR, and the plooge pattern is for brightness adjustment of the black levels. You adjust the black levels using the brightness control of the TV. So let me go to the chapter repeat, which is a good idea for the disk in general. We use the repeat mode and set it to chapter repeat, and that means we stay at one test pattern without losing it. Yeah, actually, this remote is easier. Thank you. Okay, now if our brightness setting is too high, what we will see here, this element here is below black in PQ. Below 0 nits in PQ is not existing, so we don't want to see it. The reason why we see it is the PQ curve. All of the contents that are created and put onto UHD Blu-ray are in the narrow range, or formerly known as legal range. So in a 10-bit word, this goes from 64 to 940, and essentially we don't want to see anything that's below this threshold, this 64. In adjusting the black level, we want to make sure that we get a maximum of contrast, like the black should be a deep black, and B, we want to make sure that our blacks are not crushing. So we have some steps of brightness here, starting at 0.01 nit and going to 0.1 nit. So we see different steps, and our brightness setting is actually too low if some of the steps disappear. So now our challenge is finding a position where we have a good black level as well as a good representation of these dark steps. And I don't know if you can see it, but the standard setting is actually pretty good. The standard setting is 45, and if I go to 46, this bar appears. Are you able of seeing that? Good. So this is the brightness setting. The next thing we want to do is we want to set up the contrast. And there's obviously something that we need to explain about the pattern. Now, if we change the contrast in this pattern, what we will see is that there are specific parts in the image that are starting to appear. If our contrast setting is at 100, these parts of the image they don't appear. But knowing that the disk was mastered at 1000 nit, we also know that we don't want to see the error between 2000 and 10,000 nit, because the mastering display could not reproduce it, and the person who was mastering the disk could not, or the content itself, could not see anything above 1000 nit. So our target in reproducing the levels of brightness is actually everything from 0 to 1000 nit. Please feel free to ask questions anytime. Let me.
So, what about in years going forward if we have LED TVs that exceed 1000 nits? Is this going to become like less? I mean, are you going to be able to move the goalposts to have it where maybe 2000 is where 1000 is now, and would that require an entire new disk, or would it know to properly allocate the luminance?
Okay. I had this question before. Do we need to do a different calibration when the mastering situation is a different one? This is one part of the question. And what do we do in 2 years from now when the TVs can do like 2000, 4000, whatever nits, right? The answer is the TV needs to follow whatever the metadata of the source is telling the TV to reproduce. In this case, our situation is that everything should be reproduced up to a level of 1000 nit. If the TV's capability would be lower, can you go back and turn on the chapter repeat, so that would help speeding it up. Thank you.
Yeah, you should go and lower the contrast one more time.
Oh, excuse me. Yes, I will do that. I'll come to your question.
Sure.
Okay. Now, let's go to the contrast setting. Okay. Once again, the mastering situation tells us with all the metadata that is transmitted by the disk and over HDMI. It's part of the HEVC encoding, and it's part of the signaling that goes on over HDMI. It tells the TV that the mastering situation did work with a maximum luminance of 1000 nit. So our primary goal is reproducing this everything that is up to 1000 nit and still showing differences like 950 and 1000 nit. We want to have a maximum contrast in between the dark areas of the image and the 1000 nit. We would have misadjusted the TV if the contrast was too low and our highlights, which appear to be highlights on the mastering display, would not be really bright, would not be representing the contrast ratio.
So you're essentially losing contrast ratio.
Is there the other microphone that you can?
So you're essentially losing contrast ratio in the mid-range of the picture if you do that, right?
Yeah, you're losing contrast ratio for the highlights. I mean, even your specular highlights in the image, they are getting reduced, and the whole depth of the image, the whole contrast ratio in the image won't be the same. And at the same time, your midtones are getting dimmer as well. So this is not something you desire. What you desire is you want to reproduce what the mastering situation was. Like your professional monitor did go up to 1,000 nit, or it did go up to 4,000 nit, which would represent what the Dolby monitors can do. So now the TV is not capable of reproducing 4,000 nit. That's our primary problem here, or not problem, maybe more like
Area for improvement.
huh?
Area for improvement.
Well, it's a communication system, and you need to. The TV needs to follow whatever the source is. And I would like to interrupt this and go to the clipping pattern because I think it's a better representation and a better answer. Do you have?
I have a
Yeah, clipping pattern is in the advanced section.
Florian, what's the purpose of the shutters?
The purpose of the background changing is that the APL is changing, and the APL of the picture could affect your contrast setting. Some display technologies have a very high dependency on APL. So,
Right, so we should see consistency across the
yes,
across
that's the goal.
pattern.
That's the goal.
If that starts to pulsate, if that starts to change in any way,
We should see consistency.
is that a power
Over
supply or a processing issue, or
the question that you're asking is the APL. Is it dependent on power
well, I was just asking if we're seeing the APL change and we're seeing some sort of effect on the pattern, which we shouldn't see. What's usually the cause of that? What should we point to?
Yeah, some of it is a power consumption restriction. Some of it is like you want to avoid overheating. You don't drive your engine of the car at full RPM all the time because it will blow your engine. And it's essentially some display technologies are more dependent on the APL level, and others are less dependent. But
Where do you want me?
yeah,
Sorry?
in there, the
That's
first
what I
pattern,
thought.
and
And then
we may even pause it because we can see the indexes.
Okay.
So
you want to do that now?
yeah. No, for at the beginning, please.
What do you want to do? What do you want? Oh, to all of them and now pause? Gotcha.
Okay, I think this is a better answer to what you just asked in terms of what happens if we see a higher.
The remote's in Korean, by the way.
Yeah, that's why I'm struggling a little bit. Okay. So contrast setting. See this is a clipping pattern, and we have indexes that would represent the IRE levels, and at the same time tell us the absolute light level according to the PQ curve. So in this case, J, the index J, which is here, would be 1,000 nit, and we want to have the display clipping at above this level, and following the PQ curve as long as possible. Now, in a situation where you have a mastering metadata that says, for example, the pattern was mastered or the content was mastered for 10,000 nit or for 4,000 nit, this is a simulation of what happens. You would show a lot more differentiation, but hopefully you would follow the PQ curve as long as possible. Like your TV might be restricted to 1,000 nits, and in an ideal scenario, you follow the PQ curve as long as possible, like maybe up to 800 nits, and then dedicate the remaining like 200 nits for the area up to 4,000 nits. That's just an example. So in reality, this whole system is ready for mastering monitors to change to 10,000 nits or TVs getting brighter and brighter. And the reason why it is ready for this is because of the metadata. The whole system of HDR10 is dependent on the metadata, and the flexibility comes from the metadata. Does that make sense so far?
Yeah. I mean, it sounds like what you're saying is that the disc doesn't really care what the output is of the TV. It's going to show whether you're clipping or not based on your capabilities and not so much based on the actual nit measurements.
So the disk is containing metadata, and the metadata is in accordance to the mastering situation. So the metadata actually tells the TV what the mastering situation was all about. It tells the TV that the person who was mastering the content at a display that could do 1,000 nit couldn't see anything more than, this being differentiated. So it's not our goal to show these levels of luminance, because the person who created the content could see it, right? Now, if the mastering monitor was 10,000 in monitor, the display has to do something with it, with the information, and in this case, it would show further differentiation.
So actually, Florian, I think he had an interesting question, though. Let's say 2 years from now, this display does 4,000 nits, but this disc was mastered at 1,000. Does it still work as an evaluation and a calibration tool for that much brighter display device? That's what you were asking, I think, right?
Yeah. So the question is ideally yes, because you cannot expect anyone to calibrate for any situation that might be out there. Ideally, you calibrate for one situation, like a 1,000 nit P3 situation, and then the TV works well with other situations. What you can do is you can evaluate. You could use a disc like this and evaluate what the TV is doing, but
because even with brighter displays down the road, you're still going to have content that was mastered at 1,000.
Yes.
Right?
Yes.
So that this would still be valid for that content as well. But like he's saying, we can't calibrate a single display for 5, 6, 7 different mastering situations, right? That'll just drive everybody crazy. It's not practical.
So hopefully you calibrate one situation, and then you just see if the display in a different situation performs well or not. So, and if it doesn't perform well, you would just go after the manufacturer, or you would go after whoever had the crazy idea of using this strange metadata, like 10,000 nit or so, because no display at this point of time can do a 10,000 nit HDR. Well, there's one JVC rear projection thing that can do 10,000 nit, but it's restricted to 2K, so it's not there yet. So again, these patterns here are patterns that you can use without any measurement devices. So this is only a Blu-ray player and the adjustment capabilities of the TV. And I think it's important, to have this kind of a possibility. So. Another thing we can look at is the color saturation and the general color decoding, but color bars are a very good tool in order to do the color saturation, to calibrate the color saturation. Ideally, I'll just switch over to the RGB only mode. So let's explain a little bit of this pattern. We have a 50 IRE background and 50 IRE colors, and when we are picking one chroma channel only, our background should match the luminance of the color. So turn it off, and you will see this has active info in the red channel, as well as this has active info in the red channel. So if I go to the red only mode, we hopefully see that the luminance is matching. So let's see the same thing in green and try to change the color saturation.
This is exactly the same thing that you would have done with SDR if you were looking at color decoding or color saturation in an SDR system as well. It's just with a different set of levels for HDR, obviously.
So if your color saturation is too high, color bars are obviously brighter than the background. If the color saturation is too low, you'll see two things. It's darker than the background, and in those color channels where there is no green at all, it will appear, and the reason for it is they get gray. So they are desaturated and therefore getting populated by the color that should be there. And just in case you're not able to make it match, you know that the color decoding is wrong. So, for example, if you don't find a position, where the background and the color bars match, it could be possible that 2020 is converted to 709, and the color decoding is based on the wrong coefficients. So, these things you can see easily by just looking at the RGB only mode. Questions so far?
Is there any way to use a test like that to see how the color mapping is going when they're up converting? Like people have started to automatically up convert 709 to like HDR10 or quasi HDR10. Is there any way to test, quantify that, or I've just got to keep staring at the different screens?
Yeah, see, when you could use either those 2020 based color bars, for example, or you use regular 709 color bars, and then when you use this, you could analyze what's going on. Like if it's up converting to HDR, it hopefully has does a conversion between 709 and 2020 instead of just ignoring it or so. But you could easily see if something is wrong in using the test patterns. If I would look at is the conversion done correctly, I would use a SDR, SDR to HDR. I would use a SDR test pattern and see what's going on. However, the problem with that is that it's not intended. When you do the conversion, it's not intended to be accurate with test patterns anymore. You could get a clue, you could find out what's going on in general, but you could not say, well, this is all wrong because the SDR test pattern doesn't show up properly anymore. Yeah. So there is no clear standard for how do you do SDR to HDR up conversion. This is more a question of taste, a question of what each individual manufacturer wants to highlight, and it's a little bit based on the display's capabilities and so on. So in that case, converting, I would say the best is to look at real content and see if it makes sense or it doesn't make sense. But back to the question, there are issues going on, and sometimes they need to be fixed. Yes, So things that I've been seeing were like when you're using a generator for HDR, and if you're not in the RGB mode for this generator, there's a good chance that the matrix coefficients are wrong, and even your test patterns are not correct. So we'll have more reasons why it makes sense to use a disk instead of a generator in order to do measurements. But yeah, that will be covered later on. Yeah, then obviously we have the same things like we had in SDR, sharpness control. The one thing that I want to highlight with HDR is you need to be much more conservative when you do picture enhancements. It's really because edge enhancement, for example, is clipping much earlier, so it makes a lot of sense not to over enhance HDR. And at the end of your adjustments, you should look at a combined pattern where you're able to see if any of the adjustments that you made lead to a picture that's compromised. And in this case, we can see that we have a smooth 10-bit gradation. So the player is set up correctly. It's not reduced to 8-bit. We see that the clipping is above 1,000 nit. So, for example, if you use RGB conversion in the Blu-ray player or so, it could happen that the clipping is down there somewhere, and so it makes a lot of sense to look at where your clipping points are, because many different settings in the player, even in the player, I could go to the picture mode setting and change things here. Can you? Oh, that's too bad. The chapter repeat is off, so.
That's the last one.
Yeah. Okay. Repeat mode. Chapter. Okay. So if we, so I'm now changing the picture setting of the Blu-ray player, and I see that it's clipping at a different position. So all of this is affecting each component. This is I've seen reviews where it was stated that there is not enough control over the brightness of HDR and so on. Essentially, you have a lot of this in the player, and there are other options as well. But so we want to make sure. Essentially, we want to make sure that we are not clipping at a point where it shouldn't be clipped. Now, I think it's a good point to start with the workflow.
Okay, let's get a target up there.
Florian is the best place to, with regard to the Samsung player that many of us are using, is the best place to keep those picture settings for purpose of calibration in their default 0 settings?
Go to user mode and they're all in 0. And that's another thing. If you're in the wrong mode, you could be clipping or having problems too. The user mode in the player is where you want to set the player. And then everything's at 0 and your levels will be fine.
So the Calman workflow that you'll be seeing is specifically made for the disk. It doesn't need a generator.
Yeah, and back to what I think one of the first things Florian pointed out is SDR test patterns do not work for HDR evaluation or calibration, right? So we have generators on the market right now that have metadata in them. You can even configure the metadata, put the metadata in the stream, kick the TV into HDR, but you got to remember the patterns are still SDR patterns. They're static, They're not HDR specific, and therefore most of what you would do trying to calibrate a display with a generator system like that would be wrong. And that's why Florian came up with an HDR specific Blu-ray test disc in order to be able to give us a tool to actually be able to make evaluation and calibrate the display to a degree. It's the first such tool that actually will give us reasonably accurate results, right? So let's go through his custom workflow in Calman. You guys, some of you I know must have 5.7 Calman. There is an HDR10 workflow in there. I don't know if you've looked at it or not. If you have, you'll see that this one is considerably more comprehensive than the one that's stock from the software manufacturer. So it's similar to other workflows. You're prompted to find your meter, initialize if necessary. Here's where we're going to look at setting up our targets, light output in nits or candela per meter squared. The peak white target of 1,000 nits is not for the display, but it's because the source that he made was mastered with 1,000 nits. And that's an important point, actually. Maybe you want to elaborate on that, because if you're putting in the number for the display and it's different than the source, your result is not going to be correct. The source is the master, correct?
The source is the master. See, there is, if you look at the different options on how to calculate the delta E values, there's one other method, one alternative method that would have the maximum light output of the display as a relative. So for example, if your HDR display is capable of delivering 300 nits max, this alternative method would say, well, my target is now 300 nits, and it's not correct because the content was mastered for 1,000 nits. So the delta E values should be related to whatever the mastering situation was, and 1,000 nit is a very good starting point because it's what is being used most.
Right, because if you do it the other way around and you put the luminance value for the display, then it makes the display look correct. You're not getting the right result because you're not setting up the reference as the source. Right? So this section here is basically evaluation, and so we'll start by measuring the peak luminance of the display with several different window sizes. But first, here's where you can just make notes on the display model, notes on the environment if you need to. Record all of the settings before you do anything. For reviewing, I think that's kind of important. And here we come to the first of 4 luminance levels with window sizes. This one is going to be 10%. Okay, and we did this before, but I'll do it again. Here's your information from the measurement right here. Just click on this.
Oh yeah,
What happened?
You have to redo it because you pressed at a moment where it was black.
Oh, okay.
Yeah.
Thanks. This should be a much higher number. There you go. So there's your values for the 10% window. Next page is 25%.
Oh, I'm sorry. Yes.
No problem. You got it? Click on the measurement for 25%.
Now you will see that this window is changing position, so it's slightly moving, and we have some bars on the top and bottom to change the APL and make it, obviously a non-static pattern. So the TV does not, whatever technology it is, does not recognize a still picture and reduces the brightness. There will be some brightness reduction depending on the model of TV that you're using, and that all of that is fine. But if you use static patterns only, it will be a more significant change.
That's another example of HDR test pattern versus SDR. It's dynamic, it's not static. That's extremely important for your measurement accuracy.
That's going to keep your backlight operating. So that'll keep your backlight functioning the way it's supposed to in this instance.
I guess that's a
different
fair
for
way
a
to put it.
static pattern. In other words, static pattern would handle the backlight differently.
This is mic off.
It allows for more stable measurements, basically, compared to static images.
Keeps the display from luminance shifting down.
Yeah.
What it does is slow the luminance shift down and keep it from falling as low as it would as if it were a static pattern. It still happens to a degree, but it lessens that problem, which means the readings you're getting from your meter are going to be more accurate. If it's going down very fast and very far, your readings are going to be crazy different as that happens. So which one's right? So we slow that process and you have more stable readings, essentially.
Motion, a picture with movements in it is more realistic than a still picture.
Okay, I think we traveled on to, you want to go back to 25 for me real quick?
Sure. So there's always an indicator, and in the workflow you have,
Right here.
yeah, and then there is a description of which chapter it is on the disk.
Yeah.
So it's always referring to where you need to go on the disk.
Take the measurement, and the manual has that information in it as well. So now it's a little bit lower at 25 than it was at 10. Let's go to 50.
Wait.
Yep.
Okay.
Here's 50. Again, a little bit lower. Your correlated color temperature and your delta E are here. They're remaining fairly close to the same. And finally, we go to 100.
And the ABL dependency in general is one of the important quality factors for HDR display. So measuring these different sizes of windows actually makes a lot of sense in order to see how ABL dependent the display is.
Okay, so the next step in the flow is measuring black level. And there are two different patterns to do that.
See, this is not perfectly centered.
Okay. So we'll take a measurement of this one, 0.02.
So question is, why don't we just use a black image? Why don't we just use a black picture to measure the black level?
And you probably know, feeding video black to a lot of LED backlit LCD panels shuts the backlight off. You get a reading of 0. What does that yield you? Contrast ratio, infinite. Nothing is infinite, we know that. So he's keeping elements to keep the backlights alive so we get a meaningful number. So you have two different patterns that have some kind of illumination keeping the backlight on, measure them both, and then probably go with the lower number. So we got 0.02 on that. Here's the other one. This one will probably be a lot lower. It is a lot lower.
Yeah, it makes a lot of sense that this number is lower because this TV with all the local dimming that is going on here has a good ability to dim down the center of the image. There is no light. I mean, right now there is light, but now here is no
Once
light.
that lettering goes away,
Yeah.
there's nothing. You want to measure it again?
Yep.
pretty much the same number.
But then you could, use either one of the measurements and find out what a fair result would be.
So here we go. Color management. You can see it will calculate the coverage of P3, P3 being the color gamut reference. And you start with white. You see it's all populated because we obviously did this before, but we'll take a little bit of time and do it again. Here's your data. Here's your target. Here's your delta E. Okay, and then this pattern, dynamic again, 50 IRE, 50 IRE, 50 IRE, which is of course different than it is in SDR. We measured patches at 75% for color, right? Again, levels are different in HDR than SDR. That's why the pattern has to be very, very different.
75. If we were at 75 IRE, we would measure at 1,000 nits, which is not something we should do. We can, of course, we can do this in order to check what's going on. We'll see that later. I mean, it is always a good idea to see what the color gamut is doing when you change the IRE level. Hopefully, the color gamut is not shrinking too much when you have a low IRE level or a high IRE level. So ideally, the color gamut stays the same. However, it makes a lot of sense to measure at 50 IRE, since 50 IRE is 100 nit, and most values in the 10-bit word and PQ are dedicated to the area between 0 and 100 nit. So we have half, like 50% of the values are for this area, and then the next 25% of the values are dedicated for the area between 100 and 1,000 nit, and then the next 25 are dedicated for 1,000 to 10,000 nit. So actually this area up to 100 nit is very important, and it's also reflecting what average content levels.
I was just going to say that the average light, the luminance level of an HDR movie is about 100 nits, correct?
Yeah, it's more 100 than 1,000.
There you go. How is our timing? Should I continue to measure, or 15 minutes?
Yep.
Well, I don't know that I have to measure all of them. You can see that they're populated. At the end, you get this, which is a valuable number for you guys. Everybody wants to know how much of P3 is it covering. You get that calculated for you. And here we can get into actually calibrating Grayscale, and then afterwards color gamut. So we have 50 and 100 IRE windows. Is that 100?
Yes.
Okay, let's go to 100 first. Continuous. Here's our data. Here's our target. So actually, we're real close. But I'll go in to the TV. Three 313-329. We were pretty close, obviously. Let's try 50.
Let me change the pattern first.
Yeah. Gotcha. Okay, so we're a little red at 315330. That's 313328, very close. So here you have a tool where you can actually do some grayscale calibration, color as well, which is next.
Should I go to the magenta right away?
Yeah, why not? Play with magenta. Okay. And you guys have done all this in SDR 100,000 times probably. All right, so where do we want to go here?
We've selected magenta in the custom color space.
Right,
Now
and
we are trying to move the coordinate to the target.
and you can see it's plus red. I got the wrong color here. It's not doing anything.
Is it measuring? Oh, you need to infinite.
Now it's a little nuts, isn't it? Now it's minus green. You get the idea. Now look at our deltas are relatively low. Luminance is a little high. Oh, there we go. We could take equal parts of red and blue out of there and correct that as well. But you get the idea.
So now, if you were interested in a different light level, we could just go to another IRE, like 75 IRE. And then you see these deeply saturated reds again. Yeah, and hopefully even at that level of light, the color gamut doesn't shrink.
We hope it's very much the same. Why is that not working?
It's covered by the magenta.
What's that?
The magenta measurement before is covering up the reds right underneath. See? Yeah. If you had it set magenta and it accidentally measured red. So it's
Selected though.
yeah, but it's underneath the magenta. See it?
Yeah, so we moved to the red while it was still measuring magenta.
Okay.
So essentially,
Oh, so you're back to magenta? Okay.
yeah, but that's at 75.
Okay, so there you go. So now you can see there's a little bit of an error compared to 50.
But so in calibrating the gamut, it's always a question of trade-offs. You know, it's how far you want to go. Do one IRE level for calibration and check another level in order to see if what you've just done makes any sense. Okay. So we have 3 more minutes, but essentially I think we should spend them on question and answers.
Go for it.
Okay, going back to the clipping pattern that you showed us earlier, one of the things that I noticed was that the red channel in particular did not, or it clipped earlier than the other channels. When we look at that, what are we actually trying to optimize on that?
Yeah, here. And then maybe we use the color chart. When you look at the manual that is out there, you will see that we're talking about a 2.5 IRE difference in between the steps. So of course we have some sort of tolerance going on, and we're still, I think plus minus 2.5 IRE for clipping levels are fair. Can we get back to the beginning and pause it? Okay, so it's clipping after I, which is 800 nit, and if we look at no, this doesn't help in explaining. This goes out to 2020. We would need to see the 2020 color space in order to explain that better, and it's not there on the diagram. However, some distances between white and the fully saturated colors in 2020 are in P3 are. I would need to draw it, but essentially the distance between white and the saturated colors is different. I need a drawing too.
So my question really is just to understand fully, knowing that the different color channels are clipping at different levels. We've got essentially a luminance, black and white luminance pattern in the middle. If we know that we're targeting 1,000 and that's dead on, that looks great. But is there something that we should be looking for? Should we be adjusting our settings to a compromise in the event that one of the channels is clipping prematurely?
This is more like showing what's going on and comparing different situations where do adjustments. I would not say that at this point of time your goal could be to have the exact same clipping points for all the chroma channels. I think the system is evolving, and there are many dependencies. One among them, we have the tone mapping, we have the color gamut remapping. So we are working in a 2020 container. So this is like fully saturated red. It's a red at 100 IRE in the 2020 container. Now, the metadata is telling the TV that it should not use the full 2020 space. It is restricted to P3. So because of that, the TV is doing some remapping, and of course this mapping is not the same in all of the channels.
Correct me if I'm wrong, but if you wanted to try and reduce the clipping in the red, you'd be taking the contrast control down. You'd be then actually losing your contrast by doing that in white anyway. So is that fair to say?
I would like to put it simple. Don't do that right now. It's too yes. So it's fair to do the 100 nit and 50 IRE calibrations but if it goes much further than this, with any of the sets available in the market, you're going to have a hard time, and you don't have the controls. Unlike there is a 3D lookup table and everything, it's going to be a challenge.
These kinds of errors in remapping, or these kinds of differences, though, in remapping to the different color channels, or that's not going to be anything that's going to be visible in program material necessarily.
See, this pattern, for example, is being used in some of the production workflows as well. The 16-bit version of this pattern is part of a workflow, and then you can compare whatever your preview is with whatever your encoding is, and make sure that you're clipping at similar levels, and therefore have designed a system that is fully functional. This is among the things that you can do with this pattern. And again, we don't expect the clipping points to be at the exact same positions, because we are doing some remapping here, and this remapping is, to some extent it is standardized, to some extent it is following whatever the display can do, and so there is no 100% answer.
Okay.
More questions?
So you said that this is being used for mastering HDR content right now. Like, basically you're mastering at 1,000 nits for displays that do 1,000 nits. So are we going to get to a point where we have HDR discs that have like nit numbers on them, so we can buy the right ones for the right TVs?
That's a very good question, man. I doubt it.
Yeah, I'm not saying anybody here is in charge of that. It's just scary.
We can't even get UHD Blu-rays half the time to tell us what the color space on it is. Is it wide? Is it 709? I mean, sometimes it tells you, sometimes it doesn't.
Well, hopefully a lot of the cinematic content is PS3, and if you would be to add, if you would add the maximum luminance to the descriptions on the disc, it can be confusing, because the mastering display, when it did the maximum luminance, was it capable of doing this maximum luminance at full field? Or was the mastering monitor restricted? We have so many variables in this system that I don't think it would help. Hopefully the content creators will use consumer TVs in order to see what's going on when their content is played at consumers' homes. Actually, we're now much closer to the cinematic intent, because we do have the PS3 gamut. We do have a situation where the TVs that we're using at home are close to what the mastering monitors can do. And in some situations, the TVs that we have right now are even better than the mastering monitors that are being used. So it is an interesting situation where consumer technology is actually kind of dictating the further proceedings in creating content. And we have a flexible system. So this is a very important part. With HDR10, we are prepared for up to 10,000 nit. We are prepared for any color gamut you can think of that is in between 601 and 2020. So whatever is coming next in terms of display technology, the system is prepared for it. And that's actually a very important part of this new flexible system.
Don't forget to record your settings post-calibration.
Thank you, Kevin and Florian. You guys want to hang out? We're going to just put the TVs back up, and any more questions, we'll be here. Unless you guys want to get online and spin the wheel for a free t-shirt. Thanks for coming, everybody.